Welcome friends, till now we had learned about block diagram analysis techniques. From this video we'll be learning about a new method of control system, which is the signal flow graph, which is a lot easier method than the block diagram analysis, and a huge amount of tough problems can be done with the help of signal flow graphs quite easily. So let us start with SFG, which is the signal flow graph. So what is a signal flow graph? Suppose we have a block diagram. Suppose this is a block diagram G3, G1, G2. Okay, this is G3, right? This is adding up. There is another block G4, and there is a negative block out here, that is my H1. Suppose this whole thing goes on to this part. Okay, yeah, maybe looking at this sum, this is not that complex. It can be solved easily with the help of block diagram analysis, quite right. But there are this is just an example which I made out right now. There are problems which are really tough and we cannot solve that easily with the help of block diagram analysis. Those sums have to be represented with the help of SFG. So what is an SFG? SFG is the technique by which we will represent it with the help of straight line graphs, that is signal flow graphs. Signal flow graphs, if we want to make this a signal flow graph, what things do we need to remember? Number one, that each takeoff point or each summing point acts as a node in my signal flow graph, and these gains are just the values that we write on top on the branches. Okay, like let me give you an example and that will be very clear from this. This is the summing point, right? So first of all the R comes in, this is point 1. Okay, from there we go on to takeoff point, there is another point in this direction with the gain G1. So we write G1 on top of this loop, on top of this branch. There's another summing point, so that's represented by another node. We represent it with the gain G2. There is another takeoff point here, and a gain of G4 comes to it, right? G4 comes to it. Now we can see that this path there is also another gain, that is G3, right? G3, another path. This is directly represented, and there is a last path from G4 to this path, that is the first point, this path. Here you remember, if we give a minus sign, if we have a feedback path, we have to give a minus sign out here, that is, this is minus H1. This is the first thing that we need to do, that is, this whole block diagram we can represent it with the help of this thing. This is a signal flow graph. Now in signal flow graph also, what do we need to do? We need to find out the transfer function of the system. Now to find out the transfer function of a system, we need to find out some very basic things. The basic things, number one, is what are the paths? Okay, there is a thing called a path, and there is another thing called loops. Paths and loops. Now, a path is any way that we can reach from the starting point, that is R, to the C. We have to follow the directions, obviously. So if we move from this point, this, and this, we can reach to the output. So this will be one of my path. So my path 1, we have to write the loop gains for the path. We move through this G1, this G2, this G4. So the total gain would be G1, G2, G4, obviously. Now the path gain number 2. Now the second path, can there be a second path? Yes, we can see that if you move from this, and this, there is a second path. So this is my G1, G3 and G4. Now you can see that I can move here, back and then go. But you cannot. A path should traverse a single node only once. It cannot traverse a node more than once. Okay, if it does, then it's a wrong path. So can there be any more paths? No, there cannot be any more paths. Now we have to find out the loops. Now as I can see, loop, this is not a loop because both are going in the same direction. This is a loop because this is in a different direction. So what, there is only one loop. And what is the loop gain? Loop gain is g1, g2, g4 and minus h1. So we can write it as minus g1, g2, g3, h1, right? So this is my loop gain. Is there any other loop in this? No. So there is only one loop. So first of all, if we get a signal flow graph, what do we need to find out? We need to find out the paths and we need to find out the loops. So once we have done so, we can proceed to the final thing. To find out the transfer function, the formula for transfer function here is called the Mason's formula. The Mason's formula says that the transfer function is equal to the summation of the pk del k by del, right? Where del is equal to 1 minus sum of loop gains plus sum of two non-touching loop gains minus sum of three non-touching loop gains, etc, etc. Okay, so here there's only one loop, so we need not worry about this. So this is the main formula that we have to do in every sum, that is summation of pk del k by del. And what is del k? Del k is equal to the del that we find if suppose we have a path where a particular loop is not traversed, so we will just subtract that path, that loop gain. Okay, so here there is only one loop gain, so let us do it in this way only. So what will be the del here? Del would be 1 minus of minus g1, g2, g3, h1, right? g1, g2, g3, h1. As we get is 1 plus g1, g2, g3, h1, right? Del 1 would be equal to 1, del 2 would be equal to 1 because there is no loops which are not traversed in any path. So my transfer function directly becomes, this first part is g1, g2, g4, g1, g3, g4. So it is g1, g2, g4 into 1 plus g1, g3, g4 into 1 divided by 1 plus g1, g2, g3, h1. This is the transfer function that we find out with the help of my signal flow graph. If we do this sum with the help of my block diagram analysis, let me show you this sum with the help of a block diagram analysis so that we can find out quite easily that whether we have done it right. So this graph, if we do it with a block diagram analysis, these two are in parallel. So this gives me g2 plus g3, right? This gives me a block g2 plus g3 in series with g1. So this gives me a block g1 into g2 plus g3. This also has g4 in series with it and a feedback block of h1, right? So we can directly do it as g1 g2 g4 plus g1 g3 g4, right? g1 g2 g4 plus g1 g3 g4 by 1 plus this thing, that is g1 g2 g4 h1 plus g1 g3 g4 h1. Yeah, so I did it intentionally. Now see that we can find out that the answer that we have found out with the help of this block diagram analysis and with the help of this thing, these are not same. So we have done somewhere wrong. Where have we done it wrong? In the block diagram analysis, we can see that it's absolutely equal. So that's none of a problem out there. So what's the problem? We have missed out a loop out here. Can you tell me which loop I missed out? We have done a loop g1 g2 g4 g1 g2 sorry g4 h1. This would be g1 g2 g4 h1, and there would be another loop. Can you see g1 g3 g4 h1 minus g1 g2 g3 g4 h1, right? So this loop g1 g2 g4 h1 would also get added to it as g1 g2 g1 g3 g4 h1 because we have missed out that loop, right? So that gets added and g1 g2 g3 g4 h1 gets added to the transfer function, and now we can see that both the transfer functions match. So yeah, if you're doing it new, you can clearly see that it's difficult to find out the loops every time, but if you get into the flow, you will know that loops are very easy. We'll probably move on to the next topic, that is my conversion of a signal flow graph into a block diagram in my next video. Thank you for watching.